All right. I'll just start with a quick introduction. My name is Chase Ginther. I lead a team of machine learning engineers and architects here at Snowflake. So I work with customers like Daniel here, as well as perhaps many of you in the audience. My team does to help learn new features that we're launching in the machine learning ecosystem at Snowflake, help customers adopt them into their platform, into their tech stacks. And then also the other part of my job, and the part I like most, is that I get a lot of really good feedback from folks like Daniel folks like Daniel tell me, Chase, we need this to be better. And then I take that to our product and our engineering team and help them understand what our customers are doing so that we can improve it. And so with that, I'll hand it over to Daniel to introduce himself.
Hello, I'm Daniel Stahl. I lead our data engineering team at Regions Bank. Just to give some background on myself, I've been in financial services my entire career. Every single place that I've been has had incredibly talented statistical and data professionals, and they've done some amazing development work. But the part that has always been missing is the ability to really operationalize those data use cases in a way that is effective, consistent, governed. So when I joined the Regions Data and Analytics team a few years ago, my mission was really to provide that capability around operationalization of data products to Regions Bank. And I think we've been fairly successful at that. So right now I have in my responsibility really three different areas from a data engineering perspective. I have a data ops engineering team, and that's really includes the ML ops capabilities and components that we'll be discussing a little bit later. I have a data platform engineering team. So among their many responsibilities includes administration and maintenance of our on-premise legacy data lake, which we'll also discuss in a little bit. And then I also have traditional data engineering teams, which, pipelining, ETL, that sort of thing.
Awesome. So on the agenda for today, we're going to talk, just do a little bit of overview, introduction, and some use cases. We're going to walk through what Regions had before Snowflake from an entire data platform standpoint as well. This is definitely going to be an ML-focused conversation, but it is about a machine learning platform, which is obviously, as we know, as everyone probably in this room knows, much more than just building models, right? It is the entire data stack. So we'll be talking about that. We're going to talk about what that looks like today and going forward at Regions, and what that looks like as well, and some of the lessons learned that we've jointly had actually throughout the process. And we'll also talk about a little bit about what's next, which you've been hearing about all week from some of the announcements.
So who is Regions? So a lot of you from the East Coast, so you may be already familiar with Regions. We're the 25th largest bank in the country, primarily based in the Southeast. One of our core values is focusing on the customer, and that reflects in some of our surveys and like the JD Power rankings, where we're typically within the top one or two within our peer group. But that also reflects from a personalization and data perspective. So it's hard in today's day and age to focus on customers without being able to use data to provide them tailored, personalized experiences. So about a year ago, Regions kicked off something that we call Regions 2.0, which is an enterprise-wide transformational effort that's really focused on putting the customer first. As part of that effort, we're also looking to re-platform a lot of our data assets. So I mentioned we have an on-premise legacy data lake, Hadoop-based data lake. So part of this transformation is re-platforming that into the cloud. So that's where Snowflake has come in. So what are some of these use cases that we're delivering on top of this more modern platform? So these are two that we're going to be delivering this year. The first one, personalized insights. This is actually where we're taking data insights, but also recommendations for altering behavior to our customers via the mobile app. So this is going to be providing things like telling me how much I spent, let's say on Starbucks last month. And if I spent $500, maybe telling me it might be time to cut down on my caffeine intake. So it's helping provide a better financial perspective and help for our customers. And that's available right within the mobile app. Fraud is another interesting use case. So fraud is a place where analytics has been used for years at financial institutions. But we're getting to try to improve the UX or the experience for our customers. Once a deposit is made, we will run a machine learning model on it and indicate whether or not we think that there's a high likelihood of fraud on that deposit. Today, this is done in batch. So when this flag happens, it could be after the deposit is made. And if it's high enough risk, we'll actually place a hold on that account. But from a customer experience perspective, that's not great because they think that they have access to the funds. But then they try to access it and it turns out that there's been a hold placed on it. So by using some of the more modern technologies from a data perspective, we're looking to provide 7-second response times So when somebody deposits something, they're made aware immediately whether or not they have access to their funds. So we still might place a hold on their account, but at least they know that they won't have access until after we review and work the case. So we've talked already a little bit about our on-premise architecture. So if you look at the left-hand side, there's a lot of really good tools and partnerships that we've had with vendors throughout the years. Fundamentally, the problem with this on-premise architecture is just using old technology. Hadoop, we were an early adopter of Hadoop. We did it in 2012, and that was great in 2012, but we're in 2023 now, and there's a lot more opportunities for separating storage and compute, ephemeral workloads. So we really felt ourselves kind of hamstrung by this legacy architecture. It's very batch-based, so some of those use cases I was referring to that have more of a real-time requirement just don't work well with our on-premise architecture. So going a little bit more into some of the challenges, Hadoop's complex. Like, it solved a problem, but it did not solve that problem in a way that was friendly for the vast majority of users. Having to figure out whether to use Hive or Impala, trying to understand our partitioning approach or strategy. And so whenever the mistakes were made here, and mistakes always, if there's too much complexity, mistakes will be made. It's inevitable. We found that we would have a performance hit. And part of that comes back to the fact that this is a monolithic environment. So if I have a bad job in one part of the environment, and it impacts jobs throughout the environment. It also creates a bad incentive. If I have a limited fixed cluster size, which is how we architected our data lake, and I see that there's a terabyte of memory available, and I think that maybe I need to use 200 gigabytes of memory, but I'm not sure, I have an incentive to take that 200 gigabytes before somebody else does. So people are going in there and they're taking too much, they're over consuming our lake because that's just the way that the incentives have been structured in that on-premise environment. Again, on that data movement side, because there is such inflexibility with our data lake and it's just so hard to use, a lot of folks extract data from that data lake and put it into downstream sources, which from a governance, security, lineage perspective makes it a lot harder to govern. For machine learning in particular, there's, so Databricks is actually, I shouldn't have mentioned Databricks, I'll not go there. I was going to say they actually did a pretty good job of making machine learning operational on top of a Spark environment, but we don't use Databricks today. So we are really stuck with the Spark ML libraries. So typical classification, regression type workloads, it's very hard for us to do more advanced things like deep learning. Small set of the available Python libraries are available for Spark. And if you wanted to try to Sparkify a Python library, that's not built for it. It's actually a lot of work to do so. I already mentioned the shared environment. We do see, especially in the data science area, the need for large scale data sets and for large memory needs for a lot of these Spark ML models. And it's hard for us to identify those jobs, to kill those jobs when needed, or to even provide the right reporting around that to identify how we can address these jobs and make them better in the future. And then finally, on the administrative maintenance perspective, managing hardware is not something that differentiates regions. There's this whole set of work that my team does, and they do a really good job of it, that doesn't help make us a better bank. It's something that we can outsource to a cloud provider, to Snowflake, and provide us a much better maintenance perspective. So again, in the Cloudera world or in the Hadoop world, we have to manage each node individually. We have to set config files everywhere. I mean, it's a massive ecosystem, and the complexity that comes with it is also massive. So Snowflake architecture, there's 2 slides on the Snowflake architecture. This one's a little bit of a higher level, and then we're going to dig on the next slide more into machine learning. So as part of this replatforming in the cloud, we went from snapshot-based batch loading, which is how we currently do it in on-premise, to more of an event-based streaming approach. So we use change data capture on all of our source systems that we require to bring data into Snowflake. And we publish those events to Confluent Kafka, and then Kafka will have 2 sinks, actually 3 sinks, but 2 for the sake of this diagram. The one being Snowflake and the other being Lambda on AWS. And what Lambda does is it'll write the data into DynamoDB. So we have that essentially online store for fast retrieval, and then we have the historical offline store, if you will, within Snowflake. And that's really, so that online store is really for cases where we need sub-second data. So I was at a presentation yesterday or 2 days ago on some of the dynamic tables that you all are creating. So we'll heavily use those for micro batch based workloads, because honestly, most of our use cases, a minute's fine. There's only a few certain use cases where we really need that sub-second latency. And then if we go to the next slide, so this is a deeper dive into how we're doing it from a machine learning perspective. So the machine learning platform we're terming Melkor. So if any of you are familiar with Lord of the Rings, that's a term for one of the big bad guys. So we decided to name it after that because some folks on my team are huge Lord of the Rings fans, but also because ML Core kind of sounds like ML Core. So we felt like it was a clever term for the platform. We're looking at using SageMaker for that platform, but not using all of the SageMaker capabilities. So the feature store, for example, will be using Feast. For orchestration, we'll be using Prefect. And all of those things operate in our AWS account and then interact with Snowflake via private link. So we'll be doing all of our push down for feature stores, for offline feature stores, for batch-based scoring, and just general data warehousing is all going to be pushed down into the Snowflake environment. And then from a Snowpark perspective, both data engineers and data scientists will be using Snowpark much like they've used Spark in our on-premise environment. We found that that's a very easy transition. The APIs are very similar.
Maybe Daniel, I'd love for you, because a question I get asked from customers all the time is around orchestration of Snowpark. And I know you guys have decided to use Prefect. There's a lot of tools in that space you could use. Can you talk about like how you guys intend to use that, what the ease of use looks like from using orchestration tool like Prefect?
Yeah, that's a great question. So right now, you can set up a full DAG within Snowflake tasks. We found a couple limitations there. So one, it only uses SQL is my understanding. So you can't like use Snowpark with that. Also, we wanted something that was going to be able to be used for things outside of Snowflake as well. So more of a general purpose orchestrator. So we explored a couple different things. Oh, by the way, the announcement of Python-based tasks, that could be powerful too. So we'll have to look into that. But we found that Airflow was there was a lot of boilerplate that you had to write for Airflow, and you had to kind of rethink of how you wanted to structure your pipelines to accommodate that. We found that Prefect was very easy to use. You can just take your existing Python code, add some annotations to it. The fact that Prefect runs within our AWS account when you set up the IAM policies to really easily connect to various AWS services, and then we use the integration with Vault to make connections to Snowflake.
Awesome. Beautiful.
Talking about lessons learned. So the networking configuration is something that's very complex when you are a large financial institution and you have very, very sensitive data and security concerns. So this one was the first time that we were doing a cloud replatform. It was a learning experience and a journey for a lot of teams, including, but especially my team, on what it takes to set up a very private network involving a lot of different companies and a lot of different services. The second thing is understanding the core platform. So we really dug into Snowflake. So Jessica's here. She's on my team since she's the one who operationalized Snowflake for us. But her team really dug into Snowflake and really understood all the capabilities and how we could best leverage those. So being able to dig deeper into these things is actually really important for successfully operationalizing these things. The other thing I was going to mention that's not on here, we set everything up in Snowflake using Terraform. So there's a phenomenal Snowflake Terraform provider. It allows us to have a consistent way to provision infrastructure on both the AWS side as well as on the Snowflake side. And that allows us to do things like share certain values across different states within Terraform. So an AWS service that's provisioned through Terraform can reference Snowflake objects by referencing the Terraform state. And that provides us a very consistent way to create tables, to create users. Provides a lot more auditability. You don't get the sprawl that you might otherwise get if you had like an admin user who would go in and play around with things. So we only have one admin account user, and that user is managed completely by Vault. So we don't actually have any human with those privileges, which really helps from a security perspective.
Yeah, and just a couple of things to add on that too. Back to the networking point, I think the big lesson here and takeaway is like, if you're a data science representative in this room, engage your central IT teams and those network teams early on in the process, because the last thing you want is like you to be blocked by them while you're trying to get going and using the platform. So, engage them early on in the process, and they'll work, and we'll work with them from a Snowflake side. We're happy to have those conversations and make sure everything's up and running from a security standpoint. The other point I wanted to add too on the core platform, I think this is the question I get most from customers is like, help me understand, how Snowpark's implemented versus the SQL engine, or like help me understand how RBAC works and Snowpark and how that's different from, the core SQL engine. And the answer is there is no difference, because and I think this is one thing that Snowflake's done really, really well, is that we have been building all the machine learning capabilities into the core platform. So to Daniel's point, there's so many concepts that are what I'll call core Snowflake fundamentals that really don't necessarily have a data science background, but they do because these data science features leverage them. So really embracing Snowflake and learning those can be really beneficial. So just to touch on what's been simplified in Snowflake for the regions team. So again, starting with Snowpark, Daniel's team already has had a lot of Spark experience. So with Snowpark, we were able to offer them something that was syntactically really comfortable, right? Like his team was able just to get up and running, understand the syntax, and immediately start writing code. But what did we take away from the beginning? All of the management of the entire Cloudera cluster, all the configuration, all of the diving into random container logs on random nodes, all of that pain we were able to take away and abstract, right? From an isolated environment, compute is easily abstracted in Snowflake. So you can abstract compute to whatever degree you wish in the platform, so you don't have a noisy neighbor problem. It's also very easy to set up multi-cluster warehouses for that use case as well. So you're no longer constrained by any noisy neighbors, which is, again, going to allow from an impact that makes to a data scientist on day in and day out. Again, like Daniel said earlier, their impact to the business is how quick they can deliver something of business value, right? And it's not how quick can they debug something in their Spark cluster. So this is just freeing them up to iterate even faster. And again, we talked about the administrative overhead. We've had the Terraform templates to allow for this CI/CD based deployment and templating and no more hardware management. Anything you wanted to add there?
Oh, no, I do actually want to add one thing. So on the Snowpark side versus SQL side, Snowpark is, because it's a Python based, does make it a lot easier to do unit testing, to do modularization of your code. And there's a third thing that'll come to mind at some point. Linting, there we go. So I can't, being able to actually have a certain structure to my code base, I can use because it's just using Python. And that new announcement around the mocked session will make unit testing very, very easy.
Yep.
Very excited about that.
Yeah, we have a lot of customers who use standard Python, the unit test framework in there to integrate that into their CI process.
So what's next? So I mentioned Feast. We have to get that set up. We have a POC of that. So we've sussed out what that pattern looks like, but we actually have to implement it in production. One of the things I'm really interested in is implementing a data mesh strategy, so federating the production of data. We already do a pretty good job of doing self-service data consumption, but what I'd really like us to get to is enabling self-service data production, and then providing guardrails and a framework to allow for a certain level of comfort or guarantee around the data once it gets put into production. On-premise data assets. So we have a use case driven approach today. I mentioned a couple of those. So we bring in data that's to facilitate that use case. We're also exploring ways to move more of our on-premise data sets into Snowflake, even beyond those use cases, just to enable self-service analytics.
And can I add something there? I get questions around that a lot, which is like I'm talking to data science teams, and they may have legacy dependent data that is in some sort of legacy system, and they're like, oh my gosh, we depend on all this data over here. It's in this massive Oracle database or something like that. And how do we even think about getting started, right? And I think their region's approach is absolutely the right one here. Use case driven. Start with a use case, identify the data dependencies for that use case, migrate that into Snowflake, and document a lot about that process and use that as your initial POC because you can immediately start to show back to the business the value that you're providing. And that way you can get incremental investment in that migration.
And then finally, so I presented at Nashville's Data for Breakfast in, when was that? March. And I had take a vacation on the slide. We haven't yet done that. So that's still relevant. We need to take a vacation. We've done a ton of work operationalizing Snowflake. We're going to be continuing to create use cases on top of it, but we need to remember to take a break now and then to recharge.
Awesome. So what's next for us? Again, you guys have been here all week, and some of the sessions that are mentioned here, some of them have already happened, but a lot of these, if not all of them, should have been recorded, so you can go back and watch them if you weren't able to catch them this week. But I want to just do a really quick summary over that and what we're excited about as my team of machine learning engineers as we're helping customers. So first and foremost, Snowpark Container Services. Obviously, I think the use case that was presented this week was very focused on large language models and generative AI, of course. But that said, there's tons of applications for Snowpark container services beyond the large language model use case. So we've already been talking to Daniel and Regions about use cases for just traditional deep learning based training of GPUs, maybe not for an LLM. We've been talking about use cases for hosting an MLflow API server inside of Snowpark container services. But we were talking about use cases for hosting Airflow or Prefect or additional services inside of Snowflake, again, on our container infrastructure. And again, the benefit to that, back to them, or to generally anyone using that feature, is that, again, no more responsibility for managing a Kubernetes infrastructure or some sort of other container-based infrastructure. No need to worry about networking rules, policies, etc. Snowflake manages that for you. So a lot of customers are really eager about this, and we are really excited to start working with customers now that we are in private preview. The other thing that I hope people caught this week, and this is in public preview, so anyone who's a Snowflake customer here today can go in and start testing this feature out. Look, the Snowpark machine learning modeling API is now in public preview. So now what this does is it extends Snowpark to the most popular machine learning frameworks by reducing the amount of boilerplate code that you as a data scientist or machine learning engineer have to write. So what this means is that you could very simply call our machine learning modeling API and launch a random forest model and train it and deploy it. But one thing I want to be very, very clear about is Snowflake, we did not go and reinvent the wheel and implement our own random forest model and our own library. It is built on top of the popular frameworks that already exist. It is built on top of sklearn. So under the hood, this is not some like vendor proprietary API or anything. It is sklearn, and you can still use those sklearn objects. And candidly, if you want to take that sklearn model and deploy it somewhere else because you have a really low latency inference use case like Daniel may have in the fraud use case, you can absolutely do that, but you can still train it inside of Snowflake. So really excited about this feature as well. And then we now have also released in private preview the Snowpark ML Ops API. So again, I've been hearing from customers ever since we launched Snowpark, how can I do more ML Ops inside of Snowflake? What features are you guys extending to help us do that? So we have things like our model registry as well that is now available in private preview. We also have a connector to MLflow, which is a part of this because we have many customers who have already adopted MLflow as part of their ML Ops toolchain. So really excited as we continue to extend this API for additional use cases, just beyond model registry and deployment, but also for things like experiment tracking and so forth. And then we've tons of Snowpark enhancements. So for a long time, Snowpark Python was just available in Python 3.8. Just about 3 weeks ago or so, we launched public preview of 3.9 and 3.10. So now we have additional Python runtimes available. We will continue to increase the velocity at which we release these additional runtimes as the general Python community makes them available. We are also constantly adding libraries to the Anaconda repo for Snowpark Python. So if there are libraries that you guys need that you're not able to import manually, please let Snowflake know. We're able to make that happen. We are increasingly reducing the turnaround time to get those in. We're able to do it in as little as a couple weeks now. So we're really excited about all the new libraries that are coming into the Snowpark ecosystem. All right. Thank you all so much. I hope you all have a safe trip home, and thanks again.